Okay, so let's look at some of the terminology you'll be seeing in trigonometry. So this first image right here is a lean-to shed. So it's called that because it's usually going to lean against a house. So we're going to be calculating the trusses, so the roofing component of it. So that's this area we're going to focus on right here. So if you notice that truss, it's in the form of a right triangle. So you're going to redraw it like this. And so you're going to be calculating different parts of it. You're going to either calculate this part, which is called the rafter length. You might be calculating this part, which is the base or the span, or you might be calculating this part, the height, or this part, which is the pitch, the angle that's from the span or the base with the slant length or rafter length. Or you might be calculating this height right here, which is the vertical angle. So when you're calculating with these right triangles, you're just going to be doing SOHCAHTOA, so sine, cos, or tan. Um, and so you're going to be doing opposite over adjacent or rise over run or anything like that. If you look over here at this diagram right here, these are trusses as well. And so these ones in between here, you can see there's one truss, there's another truss, there's a third truss. So there's a whole bunch of trusses. And so they're there to help support the roof, especially in the wintertime, all the snow and stuff like that. So it can take the weight of all of the snow. So again, you have trusses there, and the end one here is a special one, and it's called a gable end. It's a little bit different because it's got some extra support beams, and they're going vertical like this. And so that allows us to put plywood then to cover it up. So we wouldn't cover up the inside ones, but we would cover up the end with sheets of plywood and then with some aluminum siding so that you don't have a hole in your roof kind of thing. So to finish it off. But if you notice with these trusses, whether you're dealing with the gable end or the ones on the inside, is that if you drop down the height, you will notice that it cuts the triangle exactly in half. So then you can work with just half the triangle. So here's the full truss. So you're going to draw it like that first and then cut it. And then, so basically, you're going to use half the span and then you can work with half the triangle. And then you're basically just doing SOHCAHTOA again. So you're going to do sine opposite over hypotenuse, or cosine adjacent over hypotenuse, or tangent, rise over run, or opposite over adjacent. So let's look below here. So again, here's another truss. Okay, not a gable end, but it's just a different truss. And again, so it's just a truss. You have the span down here, so that's this length, and you can just drop the height down and cut it in half and work with half the span to calculate it. The other thing you're going to come across is something called offsetting. So that's this one over here. So offsetting the truss, if you drop down the height, it doesn't cut the span exactly in half. So with these questions, you're going to use sine law, cosine law, or the tangent law. And so you're going to be using one of those to calculate the rafter lengths. And so if you notice, the rafter lengths will be different lengths, whereas here, these rafter lengths would be the same lengths. And the pitches, the angle here and here, will be different for offsetting, whereas for just a regular truss, these pitches would be exactly the same. So let's just go over some of the terminology again. So here's a truss. So if we look back, what we were talking about, the rafter lengths, it's here and here. So that's the two side lengths on an angle. That's why you'll sometimes see it called a slant length. The bottom is going to be called the span. We could also call it the base or base length. And then with the angles, we have the pitches. So that's this one and this one. And the pitch is always going to be the angle with the span and the rafter length. And then you have the top angle, and we'll call that the vertical angle.